Sounds good. Okay, I'm running a few minutes late, I think, but it's a similar talk that I've given before. So if you've seen me before, you've probably seen a very similar talk. I usually give this talk in 10 minutes. I have 20-ish today. I'm hoping to open the floor to more like Q&A at the end, because I feel like usually you run out of time for questions. And I've also focused a little bit more on the CLI for this. But we'll just go through quickly the slides that most have probably already seen before, either online or in person. I'm going to guess green. Nope. Red. Nope. Left. Left and right. There we go. Okay. So right. So features of ethers.js. So I mean, it's basically it should be like do everything you need to do for ethers, whether you're writing a wallet, whether you're creating a dApp. More importantly, if you're creating a framework. So it supports all the type of accounts. Oh, bold things on the screen. I have to stop pointing at the screen. You can't see me pointing there. The bold things are going to be things we kind of like dive deeper into. The gray things are kind of things that exist. If you have questions, feel free to ask about them. So I'll just run through those quickly. But basically, so accounts, you can deal with private keys, mnemonics, any JSON wallet, JSON RPC. It's complete. It works for any type of thing you want to build. I already covered that. Ready. So it's ready for Node.js. It has ESM modules if you're using modern JavaScript. The browser is fully TypeScript. It's written TypeScript. It all compiles down. Very well tested, 20,000 test cases. I think it's closer. It's just over, or maybe like 99 kilobytes. It's so close to crossing that thing. It's kind of depressing. ENS support. We'll just cover things in the next slides. How's that? Again, please, anybody who has questions, like just jump up and yell out. A very reactive type of presenter. Yes. So right. So one of the key features that's different. Again, forgive me. A lot of you've probably heard this before. Like, I really want to drill this into people's minds. I think we need to make a division between what a provider is and what a signer is. Like, a provider is connected to the network. It has access to the internet. People might have access to it. It's very different from a signer. A signer has your private key. You want that like sequestered really well and that sort of thing. Also, I talk fast, so if I'm going too fast, just tell me to slow down. I will try. So, I mean, again, it supports all the basic things you're used to, JSON RPC providers. The Web3 providers, if you currently have a Web3 app and you just want to wrap your existing provider and make it compatible with ethers. Fallback provider we'll go into because that, oh, actually that's on this slide, yes. Bunch of third-party providers. I think Nodesmith does not exist anymore, but other than that, everything's still running fine. So the key thing is the default provider. Default providers are exciting because, so a default provider is actually a fallback provider which connects to all these things on the right-hand side. And the exciting thing about how it works is there's a quorum. So it's connecting to those 4 backends, and when you make a request to the provider, it's picking a random subset of the backend providers and sending the requests in a semi-intelligent way to multiple backends to get a response back. Once enough of the backends have agreed that that is the correct response, then that's when you get the answer. So if you ask the current block number, and Infura says it's 35, and Nodesmith says it's 40, and Alchemy says it's 40, well, it's going to drop the Infura one and go with the, obviously it's 40. Something's out of sync, you don't care who, somebody's wrong. Quorum is nice as well because it also means that if Alchemy was hijacked, if somebody like became malicious and was returning wrong results, who's ever attacking the network has to co-opt half of the network, half of the different APIs to actually affect the result. The example I always give of the dangers of this is you can imagine resolving ENS names. If I was able to hijack like one of these services and I wanted to make lots of money, I would just make them all return my address for any query to ENS. Yes. Anyways, we can go more into that later if people have questions. Right, I have a button. And so signers, this is where your private key lives. This is a very different thing altogether. One thing that's being added is Clef support, which is not up there. But Ledger support works again for anybody who's using Ledger Nanos. You can just use it. It works in the browser, works in the like a Node.js, that sort of thing. So BIP39, this has not been updated. There's also check now. So all BIP39 official mnemonics are supported. That's kind of enough for, I also want to point this out. When you have a UI and you accept a Java, like a JSON wallet or something, if it takes like Right. It's important that using a wallet takes time to decrypt. If it's fast to decrypt, that means it's fast for me to try guessing your password. If it takes 15 seconds for me to try one password, if I want to try 1 million passwords, trying to brute force your thing, that's 15 million seconds it takes. It's important that it takes time. And everyone wants, but can you make it take time just for the bad guys? No, you can't. It has to take time for everyone. But you can really mitigate this by putting a progress bar in your dApp. If you are trying to use your wallet and there's a little bar tick, 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 ticking across, and it says decrypting for your protection, the user doesn't usually mind as much. If your UI just halts for 15 seconds, sure, don't do that. And so that's one of the reasons why there's a progress callback, and it's all like asynchronous and fun. Yes. Yes. So E and S. Sorry, 1 second. E. So I'm sure everybody by now knows E and S. This was a bigger deal like 3 years ago when nobody had heard of it. But ENS is a first-class citizen. Anywhere you can use an address, anywhere you can put an address in, you can use an ENS name. So, I mean, for me, I use this for a lot of my things. So, new takoyaki.eth, this just connects to the takoyaki contract, which is nice because it means if I upgrade it, the code out in the universe does not need to change. If you are using my npm library, it's connecting using this. Everything just continues working, and no one has to like upgrade anything. Obviously, it comes with caveats as well. It means that I could change things on you. If you were depending on weird functionality or a bug, if you're depending on a bug in my contract, and I update my contract to get rid of that bug, well, yes, your stuff might break. So there's it's static versus dynamic linking. Choose your poison. Again, get balancing. Basically, anywhere you can put a thing, you can put a thing. Yes. Deploying a contract. Right, so one of the key things with Ethers signers is when you send a transaction, you don't get back a transaction hash, you get back the actual transaction. The biggest advantage of this is for deploying contracts. The moment that you get that, it has not been mined yet. Before your contract's been mined, you get back a contract object, which has its contract address. And so even before your contract has been deployed to the network while it's still sitting out in the transaction pool waiting to get mined, you have access to the address, which means you can write it to a database, or you can start configuring the next part of some chain of a multi-sig wallet or whatever you need to do. But it's important to have the nonce that was used for this, that sort of purposes. So yes, that's my argument for that. I'm going to fall off the stage. So this is new in V5 as well. So it's a feature that everyone wanted, and I always provided the very simple, like 12 lines of code that was ridiculous to do it. So it's now built into contract objects. So if you have a function called transfer, there's a bucket called populate transaction. All the functions on your contract exist there as well, except instead of returning instead of actually sending the transaction, it just returns the transaction object, which would result in that transaction happening. This is great if you're trying to do offline signing, if you want to send it to a Ledger Nano and give it to like a Watchtower or for counterfactual, that sort of thing. Similar, a lot of people like using ethcall on things that are non-static, just to kind of like pre-flight. There's still a lot of consistency issues, but it's a useful feature in some cases. And so yeah, there's a bucket called static call with all the functions on there, and that just returns to you like what would have ethcall basically, ethcall for non-static. Estimate. Actually, quick poll in this room. I'm contemplating for V5 changing it, because V5 is still beta. It'll be coming out of beta over the next week or so. Do you people like the word estimate or estimate gas for this part here more? All in favor of estimate? All in favor of estimate gas? Okay. The gas has it. I will make that change tonight. And then obviously transaction execution. This is what everyone's used to. It just works and does stuff. So application binary interfaces. So one of the new, well, how much time do I have? Somebody's timing this? Okay, I'll just assume that I'll get a notification of some sort. So application binary interface. So we're all used to like this JSON clump that gets knocked out by Solidity. It's been very useful thus far, but it's large. It's very, very large. Especially once you have like an ERC some number token contract. So human readable ABIs are also nice because basically it is the Solidity function. The same information encoded on the left is encoded on the right here at the top. And as you see, it's much more concise. But more importantly, if you have that line in your source code, in the constructor for the contract, it's much more obvious what function even exists on that weird meta class object that just got created. So that's the argument for that. It turns out, I think the math cited says about 1/5 the size on average of a JSON ABI as well, so that's nice. The one downfall of that, of course, is now you're embedding the ABI into your source code, which means if you change something in your contract and recompile it, that artifact file is often not being ingested by your contract. So again, pros, cons, the world's your oyster. And obviously, you have, so V5 has complete access to all the Solidity parser ABI stuff that's going on in there, so that you can convert from JSON into human readable, or you can convert from human readable into JSON, or so the one caveat is you can never really convert from SIGHASH. SIGHASH is kind of like a black hole. As you can see, it throws information away. First of all, it doesn't indicate whether that's a function or an event. But more importantly, if it's an event, it just threw away like index. But this is what you would hash if you were trying to figure out what SIGHASH to use or what topic hash to use. Let's see. ABI v2, I feel like this is no longer news. I should probably remove this slide. For those who don't know, ABI v2 is awesome. It basically lets you do anything. No matter what type of structure or thing or structure of structures or array of structures or array of structures, whatever you want to pass in, it just works. And so this slide's like 3 years old, so it's not interesting anymore. I will remove it. Utilities, there's tons of utility classes. If you need to do anything weird. An important class I think people need to start using is strings. So a lot of people I see don't realize how incredibly complex UTF-8 is, and they use, like a classic example, if you have a string, a lot of people do dot split, thinking that this is going to give them each character. It gives you each like UTF-16 code unit, which is very different. For example, the poop emoji, if you try doing a dot split, will give you 2 characters, but it's one character, right? So yeah, use this. It has a function now that actually will split code units out for you. So if you want, for example, count the length of a string, you shouldn't be doing dot split dot length, because this is giving you very wrong data, especially in the world today where people like including emojis in everything. Most of the emoji space is going to corrupt your program if you're expecting that length to mean something. It also has, like, if you have like legacy Solidity strings, maybe it was legacy Web3 strings that were kind of like a weird packed encoding. If the string was less than 31 bytes, it would stick it into a word. It has things for parsing that. I think that everything else is like fairly low level. You probably don't need it unless you're writing wallets or like doing weird counterfactual things. So yes, this is what I want to talk more about today, is getting more into the command line. So there's a command line tool called Ethers. There's a whole bunch of them. Recently I added Ethers ASM, which is an assembler. So you can write pure assembly and it'll spit out this big blob of a deployable thing for you. So again, you can see you can use ENS names wherever you would otherwise. So in a few slides, you'll see what options there are for accounts. But you can send ether, sign a message, wrap ether, unwrap. There's actually like 30 things in there now. The one thing I'll be adding very soon, because the feature I want is, and I don't know what to call it yet, but move die into DSR, move DSR into die. I'll think of a better name than those. But basically, I want you to be able to manage everything from the command line. I personally have a offline Chromebook that I've removed all the antennas and all the cards that connect to the network from. And I use my own custom signer that exports everything over a terminal QR code. So it's nice because I can put what I want to sign into that. It pops up a QR code. I can scan it. And that completely offline computer can actually get like signed transactions to the network through the CLI. Sweep is very useful. If you are a hacker and you find someone's key, you can use sweep. That's not the real purpose for it. The main reason to have sweep will, if you give it a private key, will take all the funds at that and send it to whatever address you give it. The main reasons for this is because we've all, maybe not done this, but worried about one day hitting git push and you realize, frackadoodle, you like included that private key in that thing. This gives you that quick emergency hatch to like sweep the funds out of that thing before anyone else figures out it's there. So it's a very useful feature. Send tokens as well. Also, if you're scripting things, the eval command is awesome. If you want to do everything you do in Ethereum in Bash, eval is your friend. You can pass it in like these strings, and it basically runs it against the ethers library. So you can convert 0.123, the string, into way if you're doing, again, crazy Bash stuff, or Z shell. Resolving names. I mean, basically anything that exists in ethers exists in this virtualized environment. If you want to experiment with it, there's actually a REPL. If you just type ethers by itself, you get the entire REPL. Yeah, everyone knows REPL. It gives you a REPL environment so you can just experiment. I use it a lot for debugging, especially when I get an issue. Someone's like, my transaction doesn't work, what's going on? It's nice that I can just type ethers, paste the transaction in there, parse it, and be like, oh, your gas price is 0. That's your problem. So it's very quick for debugging. ENS name service, migrate registrar needs to go away because that doesn't exist anymore. But basically, I also manage all my ENS names through the command line. I'm a command line person. I really don't like UI. I don't want to put private keys that are valuable in MetaMask. It's a browser. It's with, yeah. So yes, ENS. Do stuff. ENS is awesome, by the way. For anybody who doesn't know, I'm a big ENS fan. Use ENS. Okay, accounts. This is, I think I'm almost done. This is an example of the type of accounts you can use. So if you have a text file with a mnemonic in it, you can just use it. If you want to put a password on it, this is using the BIP39, yes, BIP39 style password. There's also a feature which is experimental, which is why it's got the XXX dash whatever in front of it. What this will do is it'll take your password, it'll run it through script for about a minute, and then use that as the password into your mnemonic. So if anybody's seen my article on swirling, basically, I'll go into it quickly. If you have a mnemonic, it makes a private key. If you choose a password, it gives you another private key. If you choose a different password, it gets you a different private key. Any password is a valid private key for a mnemonic. So what I actually am suggesting most people do is make your mnemonic, put $200 worth of ether sitting on that bare mnemonic, and then what you're really going to do is whenever you use your mnemonic, enter a password. So anyone who so you can put all your ether in, like, let's say foobar as your password. Don't use foobar, find a better password. But if you put all your real stuff with the password foobar, anybody who finds your mnemonic is going to be, they'll be confused. They won't know what it is. But they'll show their computer sciencey friends. They'll be, oh, that's quick, that's a mnemonic. They'll type it in their wallet, and they'll see the funds, and they're going to steal those funds so fast, which is awesome, because now you've just been notified that your mnemonic is in the wild. You are possibly compromised. You load up that mnemonic right away, you type in foobar to get your real funds and move them somewhere else, because that into a new protected mnemonic. So that's what I'm really trying to get people to do these days. And the nice thing about using the hardened method is if people start using swirling a lot, people are going to maybe start thinking, oh, if I find this mnemonic, I'm going to try a bunch of common passwords first. If it takes them a minute per password, they're probably better off stealing your 200 ETH rather than spending the next 5 years of compute time trying to find that password foobar. Don't use foobar, they'd probably find it in less than that, but it's still a lot of work. So yes, mnemonics work. You can specify a wallet JSON, a crowd sale wallet. You can just give it a raw private key. Please keep in mind, or a mnemonic on the command line, these two need big asterisks because your command line is visible to all processes on the computer, which means you just gave your private key away to anything that's happy on your system running. So don't use those ones. Instead, you can use this dash, and the dash will then prompt you, and once the prompt comes up, this is secure entry, you can Control-V and whatever you need to do to put your private key in there, and it's off to the races. Or you can use like a JSON RPC node you have, and the nice thing is if you're running just ethers, you get your REPL environment, and there's an accounts object, and this just, so if you did like dash account one, like a crowd sale.json, and then dash account wallet.json, and dash account mnemonic, then you're going to have an accounts object which has 3 objects in it, 3 different signers, each of which represent each of those 3 accounts. So it's also useful for creating deployment scripts. Yes, I think that's, I'm done. So, questions? Oh, yes.
Thank you for the presentation, and thank you for the eval command. It will save me a lot of time when trying to hash something. Now I've got some feature requests. Okay. One of the things that is really hyped right now is deploying your smart contract to all blockchain using the same address. ENS has done that for their new registry. Uniswap is doing that for version 2. And the cleanest way to do that is to sign a transaction with an empty signature, find which address it corresponds to given your code, and just fund this account. And if you want that to work on all blockchain, you need to use pre-EIP 155 signature before there was a chain ID in the signature. So the question is, can I do that using ethers.js? And if not, can you add it? You can, and I've actually got a Medium post on how to do it. Check out blog.ricmu.com. It's not a link up there. Oh, no, it's not. Okay, add the word blog in front of ricmu.com. I'll add it to my slides for next time. Okay. But yes, basically just pass in 0 when you're signing your transaction, and you will get a signed transaction that has disabled EIP 155. Oh, OK. This is amazing. Another question is, one of the only features that I need an extra JS library on top of ethers.js is signing ERC 712 orders. Yes. Will you be adding that at some point? EIP 712, there's a issue to create it. It's, I think maybe even you have asked for this before. I know you. Anyways, it is something that's on the list. I was really hoping EIP 712 would die and we would have a better solution by now. But yes, enough people are now using it. I'll be adding it soon. But for now, there is a implementation by MetaMask or something consensus-y. MetaMask is using an implementation that works really well. Oh, sorry, I can't hear you. MetaMask is using an implementation that works really well. The thing is, you need a private key, and the private key is hidden inside the signer. So they don't give you access to hash things. I thought that you could maybe just get the hash that you needed to sign. No, because you don't sign it the same way as you would sign the message hash. So if you just ask your private key, the signer to sign a message, you won't get the good one. So at the very least, I will add a helper method that produces the hash you need to from that library. Yes, yes, yes. And it's definitely coming soon. WebSocket support is the other thing that'll be. So I'll put that on par with WebSockets. So EIP 712 and WebSockets.
First of all, congratulations for your project. I use it a lot. So another feature request. As you deal with ACDSA for the keys, would be good if you have an option to encrypt and decrypt the data using public keys and private keys. It would be helpful if within the ethers. It's going to be used a lot because nowadays I use Ether and I need to use one of, I believe, from Parity that in JavaScript to do this. But as you have an awesome library, this will be a very good
So I have written it and it's in the experimental package, but I haven't published it yet. You're right. It's absolutely trivial to write. All the libraries are already built in. It does support. It gives you ECDH, so it's very easy to get that shared symmetric secret. The biggest issue is it's very important that people understand how to encrypt and decrypt things before they try. A classic example: imagine if there's a vote, and I need a yes or no answer from you. And what you're going to do is you're going to encrypt whether you said yes or no and publish that to the blockchain. It's important to realize that the length of it. It'll be encrypted, but it'll either be 3 letters long for yes or 2 letters long for no. So you need some way to really get through to people, like, even though you're encrypting stuff, you could very easily be leaking really important information. I mean, in this case, there's literally no value to encrypting. You just made an expensive, public announcement, whether you said yes or no. Maybe you could use French, so oui or non are both the same length. That's the trick. Find a better language. But yes. But it's, so I mean, that's the main reason I don't offer that, because I know I'll be dealing with people who think encryption is so easy. There's a .encrypt function. I put data in, and data came out. So it's more about, I mean, and I can solve these. I mean, I can, for example, choose a random number and pad a bunch of random bytes on the end so that now everything is 16 bytes long. You can't tell what it was. But there's other ways secrets can be leaked. And I agree with you. That's why it'll probably go in the experimental package. It's a useful feature to have. It's one that I've written for myself to use, but it's because I know and I'm not going to say I know all of them, but I know some of the pitfalls that people go through, and so, yes. Anybody else? Oh, yes. I think you're
The last one.
Have you considered adding elliptic curve integrated encryption system?
Yeah, it's the same thing.
Oh, but
basically
is that the scheme that you were planning to use for encryption, or was
Yeah,
it?
so basically what it does is it uses an ephemeral key. You generate an ephemeral key from the private key, you mix it with the public key, and then you staple the public key to the front of the payload. And it's just normal ECDH. Elliptic curve Diffie-Hellman.
Thank you very much.
Awesome. Thank you, thank you. Also, feel free to bug me if you see the hall or now if you want to
It's a PowerPoint. Sebastian is my name.